So in this video today, we're going to go over the second semester midterm review. So the first thing we're going to do is, it says graph and find the properties of the function. So this is a square root function. So what I'm going to do is I'm going to go to Desmos and I'm going to look at this graph on Desmos. So I'm going to go ahead and put this equation in here. So I'm going to go down here and I'm going to get the square root function there. And I'm going to do 2x plus 5, close the parentheses, click outside of there, minus 4. So now we can see the graph here. So hopefully you can see that this graph starts at -5, -4. -5, -4. That's that point right there. See it? -5, -4. We can also see the y-intercept, which is 0, -8.38, and we can also see the x-intercept. So this is kind of nice for this particular graph. This is not always going to be true. So those are 3 points that we already have, and we can go ahead and plot on our graph. So we had that our graph started right here at -5, -4. So I went ahead and plotted that point, and then I plotted my y-intercept, which was 0, -0.838. And then I also had my x-intercept, which I could see on that, and so that was 3, 0. Okay? So then I'm going to go ahead and plot my graph through those lines like that, or those points, sorry. So this graph has a starting point right here. Okay, that's really important because that's going to affect both my domain and my range. Okay, so my domain, if we look at the graph, is going to be x is greater than or equal to -5, because that's my x value up here. See it right here? -5. Okay, and then my range is going to have to do with my y values. It's right there. So y is going to be greater than or equal to -4. Because this graph is going up and to the right, it's greater than and equal to. Okay, this one does not have an asymptote, so we're going to say it does not apply. Now transformations, here's the deal. I want to actually review this with you guys. So when we're talking about transformations of the square root of x, okay, we're going to have a couple things here. So first of all, if we have an a out here, a has to do with a vertical stretch or compression. Okay. And if a is negative, so let's say it's negative out here. If it's negative, then it's a reflection over the x-axis. Okay. So then let's talk about, we got 1 over b here. So b has to do with a horizontal stretch or compression. So now what you need to remember with b is you're always going to take the inverse of what's there. So if it's a 4, it's going to be 1/4. If it's 1/2, it's going to be 2, and that's because it's 1 over b, and that means inverse. Okay, so now I'm going to put a parenthesis here. Remember, there's always a minus here. So then we're going to talk about what our h. So h has to do with movement left or right. So h is left or right. And if you recall, if it's a negative there, it's moving right. If it's a positive, it's moving left. And then we're going to talk about plus k. And k has to do with up or down. Okay, so these are all going to be important because we're going to use them in the next problem as well, or all the problems actually, if there's a transformation. So now when we talk about transformations, we have this 2 right here. So I said inverse, right? So it's going to be a horizontal shrink by 1/2. And then let's talk about this right here, +5, which means it's really a -5, which means it's moving left 5. And we can see that because the graph is over here to the left. And then the last one is this one right here, which means down 4. Okay? All right, so now end behavior. So end behavior has to do with what happens at the ends of the graph. So as x approaches infinity, what's happening to f of x? So we're going right on the graph. So what's happening to the y values? It's headed towards infinity, isn't it? Remember, infinity's up here, right? So now as we jump on this graph and we go, as x approaches negative infinity, what happens to f of x now? So everybody look, we're going this way on the graph, and whoop, right there it stops. You notice that? So that means that that's going to be my y value right here. So that's going to be -4. So when you're talking about the end behavior of a square root function, one of the end behaviors is going to be the y value of the starting point of the graph, okay? So now when we're looking at this graph, if we're get on the graph and we go from left to right, is this graph going up or down, y'all? Yes, it's going up. So now we're going to talk about the x value. So from here, which is -5, to where? This is infinity out here, right? So that's our graph. And it had no intervals of decrease, so we can put NA or none here, okay? So again, we're going to do another one of these and see if this is clicking now. All right, so let's go ahead and look at the graph of this one again. So I want to go ahead and put the equation there, and notice this one looks a little different, doesn't it? So again, we have a starting point of -1, 3. Notice here, -1, 3 right there. And then again, we have an x-intercept of 0, 2.5. And a y-intercept way out there. Okay, so we're going to talk about where the y-intercept is, okay? So, I'm sorry, this is the y-intercept. I got it backwards. This is the y-intercept, and then the x-intercept is going to be way out there to the right, okay? So we're going to talk about how to find both of those in just a minute. So what we want to do right now is go back and actually graph this. So again, I'm going to go ahead and plot those points that we have. -1, +3, -1, +3. That's where our graph started. We saw the graph go through at 2.5, and then we didn't see where it went through over here. And this was about there. Okay, so I'm going to go ahead and draw my graph to the best of my ability. It's going to go out this way, okay? So here again, this is the starting point of our graph right there, okay? So when we talk about our domain is going to be, x is going to be greater than or equal to this value right here, which is -1. Our range this time is going to be y is going to be less than or equal to, because it's going down, 3. Okay, and notice where I got these numbers from, up there and there. Okay, so now our x-intercept we're going to have to find this time. So when we're trying to find our x-intercept, we're going to put 0 in for y and solve for x. So when we do that, we're going to subtract 3. I'm going to do it over here. -3 is equal to -1/2. Oops. And then we got the square root of x plus 1 left. Okay, then we're going to multiply both sides by 2 to get rid of this. -2, actually. So multiply both sides by -2. That gives me 6. And then the square root of x plus 1. So now we're going to square both sides. That's going to be 36 equals x plus 1. So we're going to subtract 1 from both sides. So x is equal to 35. So our, sorry, that was our y-intercept a minute ago. Oh, yeah. So this is our x-intercept. So this is going to be 35, 0. It's going to be way out there to the right, okay? That's where it's going to be. 35, 0, okay? So now, we saw the y-intercept, but I'm going to show you how to solve for that one too, just so you guys have it in your brain how to do it, okay? So when we're dealing with a y-intercept, this time we're going to put y equals, and we're going to put -1/2, and we're going to do the square root of 0 plus 1 plus 3. Okay, so I'm going to work that one out over here as well. So y is equal to -1/2 square root of 1 minus 3. So this is y is equal to -1/2 times 1 minus 3. So that's going to be y equals -1/2. Sorry, that's supposed to be plus 3, y'all. Plus 3. So that's why y was equal to 2.5. So when we write this one, it's going to be 0, 2.5. Okay? So that's what that point was right there. Okay? So our asymptote, we don't have an asymptote when we have square roots, so we're going to say not applicable or none. Now transformations, that's what we talked about before. So we're looking at this number right here. So because it's negative, it's a reflection over the x-axis. The 1/2 itself tells us it's a vertical compression by 1/2. And then this plus 1 is going to be left 1, and the plus 3 is going to be up 3. All right, so our end behavior. So now here we go again. So as x approaches infinity, what's happening to f of x? So as we're headed this direction on the graph, what's happening to the y values? They're headed towards negative infinity, aren't they? Isn't the graph going down? And then as x approaches negative infinity, so as we move left on this graph, so now we're moving to here, boom, it stops again. So where's it stopping? Right there at 3. So f of x is going to 3. Okay, see it? All right, so now look at this graph. As we move right on this graph, we're going to jump on where it starts and we're going to go right. Where's the graph going? Is it increasing or decreasing? Correct, it's decreasing. So this is not applicable. Where did this graph start? At -1, and where's it going to? Isn't it going to infinity? So remember, when we're talking about end behaviors, we're talking about y values. When we're talking about increasing and decreasing, we're talking about x values, okay? So this one, graph and find the properties of the function, again. Now when I do this one, I want you guys to recall that a cube root is the same as taking something to the 1/3 power. So when I do this one, that's what I'm going to do ultimately, okay? And I'm going to do 1/2 x plus 3, and then go outside of there. No, not all the way outside of there. Let me close the parentheses. -1. And then we're going to take this to the 1/3 power, okay? All right, so you should notice this graph looks significantly different from what we did before. So notice, again, this is going to go out to the left continuing and out to the right continuing because it's a cube root function, okay? So on this one, you can see a point of transition here, and you can see where it crosses the x-axis, and you can actually see where it crosses the y-axis as well. So it crosses the x-axis at -1, 0, and it crosses the y-axis at 0.794. Actually, it's yeah, it's positive 0.094. Okay. So let's go ahead and plot this on our graph again. I'm going to go ahead and put our x and y intercepts here. So our x-intercept was -1, 0, and our y-intercept was 0, 0.794. Okay. So I'm going to go ahead and plot those 2 points, -1, 0 right there, and I'm going to put that other point right there. And if you recall, our graph kind of transitioned right here, and it went out like that, right? So it was a transition point. So it turned. Good enough for this purpose, okay? So if you look at this graph, what's the domain? X values are all real numbers, right? All the range, same thing, all real numbers. There's no stopping points to this graph. This does not have an asymptote. So now again, cube roots are like our square roots. So what is this 1/2 right here doing? This is a horizontal stretch. Remember, we always do the inverse of what there. Stretch by 2. What does this +3 tell us? 3 left. And then what does this -1 tell us? Down 1. Okay? So let's talk about end behaviors again. So as x approaches infinity, so as I'm going right on my graph, what's happening to the graph? F of x is approaching infinity as well. So in other words, I'm going this way. Where's the graph going? Isn't it continuing to go up? All right, now as x approaches negative infinity, what's happening over here? Yes, it's continuing to go down. F of x approaches negative infinity, okay? So is this graph increasing or decreasing, y'all? If I move left to right, what's happening? Yes, it's increasing. And where's it increasing from? This is negative infinity over here, right? To infinity over there. So that's what it's going to be. Negative infinity to infinity. And it had no decreasing. Okay? All right, so this one is a decay function, okay? So once again, I'm going to actually show y'all how to plot this one. So this is 4, so that's going to be my intercept, and that's going to be my y-intercept. This will not have an x-intercept, okay, because it has an asymptote right here, right? And this is, remember, growth and decay functions never go below 0. So our asymptote is going to be y is equal to 0, right? Our y-intercept is going to be that blue point right there that I put. So it's going to be what? 0, 4. All right. We don't deal with transformations here, so we're not going to talk about the domain. So I'm going to go ahead and graph this. This is a decay function, so it's going to come from up here, and it's going to go down, and it's going to curve, and it's going to get really, really close to that, but it's never going to touch it. That's why we call it an asymptote, okay? So now our domain. What's our domain going to be? What are x values? Yes, they're all real numbers. And what about our range? Remember, our range, our y values can never go below 0. So y has to be greater than 0, okay? Now our end behaviors. As x approaches infinity, so as I go right on this graph, what is the graph approaching? F of x approaches 0, doesn't it? Yes. And as x approaches negative infinity, as I go left on this graph, as I go this way, where's the graph headed? Yes, towards infinity. F of x approaches infinity, okay? So intervals of increase, do we have any intervals of increase or do we have intervals of decrease? Correct, there's no intervals of increase. There's only intervals of decrease, which is because it's a decay function. And where's it decaying from? Again, from negative infinity to where? Positive infinity. Remember, this is x values. So from negative infinity to positive infinity, our graph is decreasing. All right, number 5 says, if the parent function is of f of x equals square root of x is compressed vertically by a factor of 1/2. So I'm going to go ahead and put a square root here. It says vertically compressed, so that goes out front. Vertical compressions, right? Reflected across the y-axis, that means I'm going to have a negative under here. Translated 3 right, so I'm going to do -3 and up 1, plus 1. So that's my function after it's been transformed. Okay, the next one is a cube root, so we're going to do that one over here. So again, I got a cube root of x, so I'm going to do that like this. This one said stretched horizontally by a factor of 3. Okay, so now listen. When we do these, we're always going to make it the inverse. So this is going to be 1/3, right? And then reflected across the x-axis, that means that's going to be negative out there. And then it says translated 4 left, so that's going to be +4 because it's minus a -4. And then 5 down, -5. Okay, if you notice, every possible option is in these two functions. So when you guys do the question on the test that's like this, refer back to this, okay? All right, so this says graph the properties of the function. So now this one is a growth function, okay? So here again, we have 6. Our y-intercept is going to be 0, 6. There's not going to be one of these, so we're going to put none, okay? Our asymptote, again, is going to be y is equal to 0, because, again, this is a growth function, right? So we're going to put the 6 here, and this time our graph is going to come in like this and go through that 6 and go up, 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 right? It's a growth function. So what is the domain here? Again, so the domain is all real numbers. What about our range? Yes, y has got to be greater than 0. There's no transformations, but we're not doing that here. I say, as x approaches infinity, so as I go right on this graph, where's the graph headed? F of x, which is y, is approaching infinity, isn't it? And then as x approaches negative infinity, where's the graph approaching? F of x is going to approach 0. Because remember, we got an asymptote here again, right? That's our asymptote. Intervals of increasing. So is this graph increasing or is it decreasing? Yes, it's increasing. And where is it increasing from? Negative infinity to infinity, right? And it was not decreasing, so there was none here. All right, so this one is a log. So I'm going to take you guys to the graph. So here we go again. So once again, this one, if you recall, when we did these problems, we had asymptotes for these. So the asymptote is going to be our x value. So it's going to be x equal to -1. Notice here that the graph is approaching -1. And then our asymptote, our intercept right here is, I can click on it, it's 0, -5, which makes sense because that's what that number is right there. And then we're going to go to the right and we're going to find that other intercept as well. So we can plot a few points here, and so we're going to go ahead and graph this. So now I went ahead and plotted that y-intercept, and I'm going to draw this up through there, and I'm going to go out to the right like this because that's what my graph looked like, okay? So our domain this time, are the x values limited at all? You should see yes, our x values are greater than, so x is going to be greater than -1. We're not going to include -1 because that's our asymptote. Remember, x equals -1. That's our asymptote, okay? So our range, look at our y values. Yes, they're going to be all real numbers. Now we want to solve for our x and y intercepts. Okay, so when we're solving for our x-intercept, we're going to put 0 in for y. 0 equals log of x plus 1 minus 5. So I'm going to do this over here. So that's going to be a base of 10. 10. Well, actually, let's do this. Let's move that value first. So we're going to say -5 equals log, and remember that's a base of 10. When there is no base there, that's the base. X plus 1, and that's going to be equal to 0. So we're going to move that. So I already did that. Wow. So I moved the 5 already, y'all. So now we're going to put it in exponential form. So that's going to be 10 to the -5. And that's going to be equal to x plus 1. Sorry, y'all, when I moved that, it should have been a plus, right? So that's going to be 10 to the 5th. So that's 1, 2, 3, 4, 5 equals x plus 1. Then we're going to subtract the 1 from both sides. That's going to be 99,999. So that's going to be our x-intercept. 99999, yeah, it's way out there, okay? And then our y-intercept, we already found it was -5, but again, how would we do that? This time we would say y is equal to log of 0 plus 1 minus 5, which would be the log of 1 minus 5, and that's going to be 0 minus 5, which is -5. So this one's going to be -5, 0, -5, okay? That's where that one is. So our transformations, again, this graph would have moved 1 left and 5 down, because again, we still have our h and k. And behavior, okay, so as we move right, as x approaches infinity, what happens to f of x, y'all? F of x is going up, yep, so it approaches infinity. And as x approaches -infinity, what is this approaching? It's also approaching -infinity. Notice that? Okay, so then is the graph going up or down? Yes, it's going up. So that there's going to be no intervals of decrease here. And so as we're going, where did it increase from? Okay, so now we're talking about x values. Remember, it's increasing from here, -1, on to where? Infinity, right? So that's our answer. Remember, end behaviors have to do with y values. Intervals of increase and decrease have to do with x values, okay? All right, so here's our next set of problems. So this says find the solutions for x. So first thing I'm going to do is subtract that 2, or add that 2 to both sides. So I'm going to add 2 to both sides. So that's going to be x plus 2 is equal to the square root of 4x plus 20. Then I have to take the square of both sides. So that's going to be x squared plus 4x plus 4. And I know this isn't the same problem y'all have on your sheet, but you need to do this one, not the one that's on there, okay? All right, so what happens to the 4x? I'm going to subtract 4x from both sides. So that's going to give me x squared plus 4 equals 20. Then I'm going to subtract 4 from both sides. So that's going to be x squared equals 16. And I'm going to take the square root. So x is going to be equal to plus and minus 4. So then what I want you to do is go ahead and test that in there. So again, when I do 4 times 4, that's 16. 16 plus 20 is 36, and 36, take the square root of 36, that's 6. 6 minus 2 is 4. But what if I put a negative in there? What if I put the negative 4 in there? If I put the negative 4 in there, it's 4 times negative 4, which is negative 16, plus 20. That's going to be 416 minus 16, but that's going to be 4. Square root of 4 is 2. 2 minus 2 is not negative 4. So the answer is going to be 4, because when I check the negative 4, it is an extraneous solution. So if I say, I'm going to say negative 4 is extraneous, okay? All right, so over here, what do I have to do with this one, number 10? Yes, I have to cube both sides. Okay, so this is going to be x cubed equals negative 2x squared plus 8x. I'm going to then put everything on one side of the equal sign, so that's going to be x cubed plus 2x squared minus 8x equals 0. What do you notice is in every term, guys? Yep, me too, an x. So I'm going to factor that out first. And then I'm going to factor the trinomial. That's going to be, what are the factors of negative 8? Added together give you a positive 2. That would be plus 4 and minus 2. So now we're going to set all three of these equal to 0. So x equals 0, x plus 4 equals 0, x minus 2 equals 0. So this is going to be x equals negative 4 and x equals 2. And hopefully you remember from last semester, when you have a cube function like this right here, there are three places where where it crosses the x-axis, okay? All right, so this one says find the solution. So we're going to take x to the 4th power and set that equal to 7. We're going to put it exponential form. Base equals base, right? So then how do we get rid of the 4th? We take it to the 1/4 power, which means that's what we're going to do over here. So x is going to be equal to 7 to the 1/4 power, which is 1.63. Over here, we're going to put it in log form. So we're going to say log base 5 of 625 equals our x. Then we can do the change of base form, where we keep the base in the basement, right? So that's going to be log of 5, so that's going to be 4 when we put it in our calculator. This one we can just literally put in our calculator, and when we do, it gives us 2.096, okay? This next one, 2 to the 5th base times to the power of whatever's on the other side of the equal sign equals x. That's going to be 32. This one says use the change of base formula, so we're going to put the base in the basement. So we're going to put log base 7, or log of 7 over log of under log of 77. We put that in the calculator. We're going to get 1.977. Just round to whatever it tells you to. So this next one, 16, says change without the change of base. So 7 log base 7, y'all, is equal to 1. And 1 times 148 is 148. Okay, now over here, we got to figure out what this is. So this log base 2, we want to find out log base 2 of 2 to what power? So when I tried some numbers, I got a 7 out here. So remember, this is 1 times 7, which is equal to 7. So it's going to be minus 7, right? So that's going to be 141. All right, so the next one says find the solutions for x. So again, this time we need to condense first. Okay, so we're going to say log base 4 of x plus 15. And remember, if it's minus, we're going to divide by what's there, okay, equals 2. Now we're going to put it in exponential form. So the base times what's on the other side of the equal sign, or to the other side of the equal sign power, is equal to x plus 15 over x. This is going to be 16. X plus 15 over x. How do we get the x in the denominator? We multiply both sides by x. So that gives me 16x here equals x plus 15. I'm going to subtract the x from both sides. So that's going to be 15x equals 15. Divide both sides by 15. So x is equal to 1. All right, so this next one, we're going to take the base and take it to the exponential and set that equal to 3x minus 6. This one's pretty easy, actually. So this one's 729 equals 3x minus 6. Going to add 6 to both sides. So that's going to be 735 equals 3x. Divide both sides by 3. Remember to check these guys to make sure that you have no solution. But normally, if it's a log, the only way you're going to get one is if it's negative, okay? So now, find the solution for x. So what we're going to do here is to get rid of that ln, we're going to take both sides to the e power. So that's going to give me 7x plus 8 equals e to the 4th. Where am I at? Over here, sorry. So that's 7x plus 8 equals, I got 4.598. Subtract 8 from both sides. That's 7x equals 46.598. And then divide both sides by 7. X equals 6.657. And just round to whatever it tells you to. All right, the next one. How do we get rid of? Oh, well, the first thing we're going to do here is divide by negative 3. Okay, once we do that, then we can work the rest of the problem. So I did that first, and I ended up with e to the 11x minus 95, and that was equal to 62, right? Then what are we going to do to get rid of the e? Yep, take it to the ln. So I got 11x minus 95, and then when I took the ln of 65, or 62, sorry, I got 4.127. Then I'm going to add 95 to both sides. So that's going to give me 11x equals 99.127. So x is equal to 11.012 when I divide both sides by 11. All right, so this one, again, I've got ln of 42x minus 82. I'm going to condense this by putting that over there. So that's going to be ln of 2 to the 7th. So now these ln's, because they're on either side, I can cancel them out because I could take them to the e power, but if they're both on each side, then I know that these have to be equal to each other. So that's going to be, I think that was 128, right? So then we're going to add 82 to both sides. That's 42x equals 210. Yep, and then we're going to divide both sides by 42. So x is equal to 5. Again, plug it back up in there just to make sure it works, okay? All right, on this one, we're going to condense first again. That's what we did on the last one as well. So it's going to be log base 6 of 2x minus 5. This time we're multiplying because it's being added, okay? That equals 3. So that's going to be log base 6 of 8x minus 20. So then we're going to put this in exponential form. 6 to the 3rd is equal to 8x minus 20. That's 216 equals 8x minus 20. Add 20 to both sides. So that's 236 equals 8x. Go ahead and divide both sides by 8. So x is equal to 29.5. All right, these talk about inverses. So remember when we do inverses, we're going to change these f of x's to y's first. So that is now x. 8y plus 5 plus 13. So we're going to subtract 13 from both sides first. So that's going to be x minus 13 is equal to 8y plus 5 power. Now we're going to put it in log form. So it's going to be log base 8 of x minus 13 is equal to y plus 5. Our last step is we're going to subtract 5 from both sides. So our answer is log base 8 of x minus 13 minus 5. That is our inverse. Okay? This one over here, again, we're swapping the x and the y. And you guys should remember, if it started out as an exponent, its inverse is going to be a log. And if it started out as a log, its inverse is going to be an exponent, okay? So we're going to subtract the 7 from both sides. So we get x minus 7 equals log base 6 of y minus 5. So now we're going to put it in exponential form. Our base is 6. Our exponent is going to be x minus 7. That's going to be equal to y minus 5. So we're going to add 5 to both sides. So our answer is going to be 6 to the x minus 7 plus 5 equals the inverse. Okay? So the inverse here. Now remember, when we're doing inverses of ln's and e's, if we start out with an e, our inverse is going to be an ln. If we start out with an ln, our inverse is going to be an e. Okay? So here again, this is going to be x equals 17 e to the x plus 4 power minus 2. So we're going to add 2 to both sides. So that's going to be x plus 2 equals 17 e to the x plus 4. So now we're going to divide both sides by 17. That's going to be x plus 2 over 17 equals e to the x plus 4. So hopefully you know now we're going to take the ln of both sides, because that makes that go away. So we got ln of x plus 2 over 17 is equal to, that's supposed to be a y, y'all. I don't know what happened to my y. Ooh, hopefully y'all noticed that. That should be a y, guys. So that is y plus 4. So our last step is going to be to subtract 4 from both sides. So it's going to be ln of x plus 2 over 17 minus 4. That's going to be our inverse. Okay? Then we got y equals, actually let's make that x. We'll start out by flipping it. So x equals ln of 19y this time minus 5 plus 1. All right, so we're going to subtract 1 from both sides. That's going to be x minus 1 equals ln of 19y minus 5. So how do we get rid of an ln? We take it to the e. So that's going to be e to the x plus 1 equals, that's now gone, 19y minus 5. So we're going to add 5 to both sides. That's going to be e to the x plus 1 plus 5 is equal to 19y. And we're going to divide by 19. So our answer is e to the x plus 1 plus 5 over 19. That's going to be our inverse. So this one says, when Kanye purchased an RV, it cost $187,500. If it depreciates at 7.35% per year, and 5 years later he decides to sell it, what will it be worth? So this one, if you remember, is going to be A, and we're going to what our starting amount is times 1 minus our rate of interest times time, okay? So that's going to be 187,500. 1 minus 0.0735 to the 5th power, okay? And when you do that, you get, what did I get? 128,000. 5.43 cents. Sorry, 43. Okay. So now this one, we don't need to have that 5,000 in there. So if you see this on the test, you're not going to have a starting amount. Okay. So it says, how long will it take to quintuple, grow by 5 times if I put money into continuously compounding rate? So that account. So that's equal to PERT. Now, if it says I want the money to quintuple, that means this is going to be 5P. This is still going to stay P over there. Okay. And then we're going to do e to the 0.0925 t power, okay? Divide everything by p, so we're left with 5 equals e to the 0.0925 t. How do we get rid of e? We take both sides to the ln. So we're going to have the ln of 5 is equal to 0.0925 t. And when I took the ln of 5 and I divided it by 0.0925, which I would just do the ln of 5 in my calculator and leave it there and divide it by that number, I got 17.4 years. All right, 29. Mr. Johnson bought a house. Given the equation 174,000 times 1.0567 to the 20th power, what was the purchase price? Well, that would be what we started with, 174,000. Then it says the interest rate. And remember, we're going to pull this part right here. And if you are questioning what to do 0.0567 times 100. That would be 5.67%. And then our time is right there, so it's going to be 20 years. It says your dad inherited $25,000 from his favorite uncle and is going to invest it for you at 5.125% compounded continually. So that's our formula again, A equals PE to the RT power. How many years will it take for you to have $100,000? So there's 100,000, and we start with 25,000. And we do it e to the 0.05125t, okay? So we're going to divide both sides by 25,000. That gives us 4 here, is equal to e to the 0.0512t. How do we get rid of e again? Yes, take it to the ln. So we're going to then divide the ln of 4, which I got was 1.3863. That's going to be equal to 0.05125. I think I left the 5 off right there, y'all. T. So we're going to divide both sides by 0.05125. So T is going to be equal to 20 years, 27.05 years. I think I put the wrong answer for the last one, y'all. I think I was looking at the wrong one. No? Wait. Where in the world? Take for the quintuple. Where did I get that 17.4? Oh, that was 28. Okay, sorry, my bad. I'm sorry, y'all. I'm getting tired. So we're done. Good luck on the midterm. Definitely use your review as a guide.